All right, folks. I think I'm live again, so welcome back. Let's see if this actually worked. All right, well, I think it did. So I'll just tweet this out, and we'll see if folks are going to join in. So I'm brand new to YouTube, so I'm still figuring this out. I'm also brand new to OBS, so I'm also just figuring this out. So bear with me as I kind of get started here. Oh, sweet. Found myself. Aha. All right, cool. What I don't know is if the audio is working or not. Maybe if somebody's in the chat. Yeah. All right, cool. Audio's good. Yeah, clearly I tried to combine way too many new things at the same time, right? All right, let's kick this off. All right, cool. So hopefully some folks will hop into here. What I want to do today is I want to talk about building my own data lake using CDK. So CDK is the AWS Cloud Development Kit. And what I really want to do, the main reason for actually putting this all together is I'm building a demo of EMR on EKS and how to connect to Hive Metastore. And so we've got an EMR containers best practices guide that has a lot of information in there on how to do this. But getting this all up and running it can take a little while, right? You need to create an RDS Metastore, you need to create an EKS cluster, you need to create an EMR virtual cluster, and so this isn't very easy. And I wanted to have a way to make it reproducible and also have a way to share it with folks so they could go ahead and do this in the comfort of their own home or their own home office, right? And so that's why I want to do this today. So what I'm going to do, I'm just going to walk through the stack that I created and how it all works. And so if you're not familiar with let's see, the Cloud Development Kit, this is pretty cool. If you're familiar with Terraform, it's similar to Terraform where you're developing infrastructure as code, right? And so you write code, you push deploy, and what happens is CDK goes and builds all these CloudFormation templates for you and handles the provisioning and the deployment of those templates. It's also got a lot of nice features where you can add different resources um, to other resources. So you can create a bucket and you can say, okay, just grant access to this cluster to that bucket, and then behind the scenes, CDK takes care of figuring out all the permissions for you. So pretty sweet. If you haven't seen CDK, I find it pretty useful. There's also this AWS CDK Examples Repository, which was really useful in learning how to do it. The other cool thing about CDK is it is available in many different languages. So there is a TypeScript implementation, which is pretty much the base implementation, I believe, and then there's also Python, Java, Go, and C#. So whatever you're most comfortable in, you can go ahead and do, which is pretty awesome, right? And I'm most comfortable in Python, and so if I Google CDK Python, there is a Python reference up here, and so this will go and show you all the different CDK modules for Python. So if I want to create a new VPC, let's say, or let's say an EKS cluster, you can go in here and you can see all the information about how to create an EKS cluster. Note with the Python docs, you need to click this package overview link here because that actually gives you the README for that specific package. It's a little bit odd, but I missed that the first 28 times I visited the page. So this gives you just kind of an overview of the construct for CDK, and then how to gives you a whole bunch of examples as well. So let's actually hop over to some code and see what it looks like. So I've got two main things that I wanted to deploy using CDK. First is I've got a set of data containers that I've been working on, and they're called cargo crates. So I wanted to deploy those to ECS. And let me just pop those up too. They're on my personal repository. That's this cargo crates library. It's just kind of a fun side project that I've been kind of tinkering around with that allows me to easily export data from different services. So I can say, Docker run, cargo crate URA, and I can pull my URA sleep data, or I can access the Twitter API just using a Docker container. So just kind of a fun project that I have been working on. So if I go back to my code, what I've got is I've got a data containers stack here in CDK, and this is all in Python. And CDK has kind of a default implementation that it will kind of build for you. Forget the exact command, but it's in the getting started guide. So I think you can do like a CDK init or create or something like that, and it builds the whole structure for you. Zoom in a little bit more here. And so this is a little bit messy, but you can see that it creates this entire project over here. So it gives you a README on how to use the CDK Python project. It automatically creates a virtual environment for you, and then creates kind of a base scaffolding for you. So pretty sweet. And I've created two different stacks in here. I've got a data container stack and a glue stack. So let me hop into my data container stack. And again, this is all infrastructure as code. And it's pretty straightforward. So this is completely isolated from my other example stack that I'm going to do in a little bit. But we can see this is all it takes to create a VPC. This is all it takes to create an ECS cluster. And then you can also add buckets. And then I'm adding different tasks to my ECS cluster. And then I'm adding read-write access to that bucket to the task that gets returned. So pretty straightforward. That GitHub traffic, that's just another CDK stack. And so these are all different stacks in here. So in that CDK stack, I've got a bunch of different repositories that I want statistics on. And then I've got a scheduled task in here, which is my Fargate task. And it just runs my crates GitHub image and dumps the data out to this forklift, or this S3 URL. I've also got a GitHub personal access token that I've stored in Secrets Manager. And so let's pop over to ECS so we can see what this looks like. All right, so this data container stack is completely created by CDK, so it went in there, created that stack for me. And when I hop into that stack, what you'll see if I go into my tasks, you'll see a whole bunch of stopped tasks because these are all scheduled. And so this is just running once a day. So you can see I've got two task definitions in there, my GitHub traffic scheduled task. So that's the one that I showed over here. That's this GitHub traffic task that goes and gets me stats from my GitHub repositories. And then I've got a YouTube video task. And in my task definitions, again, this is all created by CDK. So I can go into my task definition, and this is all the information for the task. It's running on Fargate. It's got a specific role executed with it that can write to S3. And this is the container that all the container information that is coming out of there. And again, the secrets are stored in Secrets Manager, so I can kind of browse around here and not mistakenly expose my GitHub personal access token. So pretty sweet. And now what I'll do, let me do a quick demo of what the data looks like. So this is the other thing that's happening here, is this is all scheduled too. So in the scheduled task, I've just got the schedule in there with a schedule rate of every hour. So these run every hour and dump data out to S3. Now I've got my bucket, and I think, let's see, AWS S3, LS S3, I think that's just my S3 bucket. And I think that should be in a forklift repos or prefix. forklift and GitHub, let's say. Oh, let's see. That's all in here. Okay, cool. So I got a forklift bucket, and then in forklift, I got a couple different directories, and I've got my GitHub directory. So let's just do a recursive listing of that. And this, you can see all the different stats for the past few days in there. Looks like my schedule may have paused for some reason, but I'll have to check that out. That's a little bit unfortunate, probably because I did something funky. But if I do a copy of this data, demo code, and that's in forklift, you can see this will be my my stats for that Metabase Athena driver repo. And so there's my Metabase Athena driver. You can see the clones that I have and all sorts of other different info in there and popular paths. So this is a way I can just kind of keep an eye on my GitHub stats. So that's that. I'm just kind of creating this data so I can have, data to analyze and so I can keep track of what different repositories are useful. So that is my data containers stack. The other thing I'm doing in that data containers stack is I'm creating a glue stack too. So let me go down to the glue stack, and all I'm doing in that glue stack is I'm creating a database for my own data lake. I go and find a bucket, and then I create a glue crawler role. And so that's just an IAM role, grant read access to that bucket, and then using this CFN crawler construct, I create a crawler that goes out and crawls both my YouTube and my GitHub data. So again, if I go back to let's see, my glue console, you can see I've got a database in here. That's Damon's Data Lake. I've got a crawler, and this was created by the, again, by the CDK deploy command. And this is the crawler that's defined. So I just ran that, and I've got a couple different tables in there. And the schema of those should be pretty straightforward in YouTube. I've got some snippet content details and statistics. So that'll play into case later when we're doing the analysis of all this stuff. So the other stack that I want to show is my my entire big data stack. And so there's I've kind of built this out over the course of this week, and I've got a few different things in here. First, I create a brand new VPC. Then I create an RDS database, just a MySQL RDS database I can use as my metastore. And then I've got an EMR stack as well. So that is just a standard EMR on EC2 cluster, and I can go ahead and create that and specify the release label that I want, and also specify the RDS connections and the secret too. So that gets passed into the EMR stack. I also create an EKS stack. I'm mainly using that so I can actually run EMR on EKS, and then I create my EMR virtual stack as well. So a lot of things going on here. Let's take a quick look at CloudFormation so we can kind of see what that looks like in CloudFormation. So you can see in CloudFormation, I've got stacks that kind of represent all the different stacks that I've mentioned so far. So there's my data containers stack. I've got a VPC stack and RDS and EMR and all that kind of stuff. So this is all automatically generated. Here's my EMR stack. If I look at the resources on that, I created a bunch of roles in there. There's the cluster that I created. There's a bucket that I created for my log. So again, all kind of happening behind the scenes when I just hit CDK deploy, which is pretty awesome, right? If I look at that EMR stack specifically, I'm going to just dive into that. This goes ahead, creates a few different roles, creates a log bucket, again, grants put access to that log bucket for the specific role, and then figures out how to connect to the RDS database, and then spins up a new EMR cluster from inside of here. And this is pretty straightforward again. I'm defining a lot of specifics about the cluster from here. So I've got my instance count and instance type and my release label and all this kind of stuff, and the applications that I'm doing there too. So that goes and like spins up that whole cluster. Now the big thing I wanted to show here was, okay, how can I kind of connect all these things together? So back in app, I've created my VPC, I've created my RDS, and the RDS is pretty straightforward too. It just creates this new database instance, specifying the MySQL engine version, and that's pretty much it. I love that one, it's so simple. And then I pass that into my EMR stack, and inside the EMR stack, that's where kind of all this other stuff happens. So I'm building up the configuration in there a little bit manually from all the information that gets passed in. So before you saw me kind of pulling out the RDS host name. So there's my host name, and I'm pulling this all from Secrets Manager. So that got created automatically in the RDS stack, and I'm just pulling that into the EMR stack here. And I can do that with the password as well. So my password down here, again, just pulling that in from my RDS secrets. So pretty awesome. And then it's going in configuring that EMR cluster. So if I go and look at that EMR cluster now, let's see. So that's over here, and I've got my clusters there, and you can see I had a few failures when I was trying to figure this out. But there is my EMR cluster, and this is set up to connect to the Hive Metastore. So under configurations, I should be able to see, where did it go? I should have my configurations in here that have the URL to connect to the Hive Metastore and everything. There we go. Wasn't showing up for some reason. So yeah, there's my username and my password and the endpoint and all that kind of stuff. So again, if I wanted to go and change something about that cluster, I could do that pretty easily. I might actually I'm not going to do that yet, but I might do that towards the end just to have some fun. So what I did, I got my RDS stack up, I got my VPC up, I went and created a notebook and an EMR to connect to that cluster. And I just needed to create kind of a sample metastore in there. So I created the simple notebook. This is the database. Now let me step back a little bit. So in EMR, there's my notebooks, and what I did is I just created a notebook and connected it to that cluster that was currently running. So again, relatively straightforward. Um, and this I did kind of manually in the console. So I created that notebook, and then I just opened up that notebook and created a new table inside of that Hive Metastore that I built up. And this is connected to the EMR cluster, which is connected to the Hive Metastore. Lots of fun, right? So then, let's see. So I created an external table. What I did is there's this Rapid7 has some pretty cool open data, some forward DNS lookups, and I used that data just as kind of a fun thing to look at. So looked at that, created that table, had to do an MSCK repair, and now I can actually just query that table from my notebook, and it's going through the EMR cluster that's talking to the Metastore. So pick up that table, filter the date, and then show some info, and this shows us all the info that is in that table. And if I want to, I can run some Spark queries on it. This one was kind of fun in the blog that Rapid7 had. They showed how to do some DNS reconnaissance, so you can see if there are domain names out there that are might be stale or something like that that you could do some nefarious things with. So pretty interesting there. But then, so back to the original goal of all of this that I want to do is to show, okay, how do I connect EMR container to my Hive Metastore? So I'm going to go back to my EMR container demo here. Actually, before I do that, so the other thing I want to do is automatically spin up an EKS cluster and an EMR virtual cluster. So that was also relatively straightforward. This is the EKS stack. So if I dive into there, it spins up, Kubernetes 119. Let's see, adds in some VPC subnets, adds some node group capacity. The main thing that I had to mess around with here was to figure out how the heck to get this autoscaler to work. That was something that was not the easiest thing in the world. Even if you're running EKS, the instructions that are out there tell you to run a bunch of manual commands, edit a kubectl control file, and apply that back to the cluster. And I like to be able to repeat things. I forget how to do things, so I wanted to be able to to go ahead and make it easy for me to build these clusters on a whim. And so what I did is I ended up building this plugin, if you will, for CDK that goes ahead and installs the cluster autoscaler. One other thing, let's see. Bear with me again for one more second. Cool. There we go. Still learning how to use computers. All right, anyway. So, yeah, the biggest thing was actually building that cluster autoscaler. I initially tried to use a Helm chart. You can actually see my poor attempts to do this inside this file here, and I'll publish a lot of these in a little bit as well. But what I tried to do is I tried to use the Helm chart first to install the cluster autoscaler because I was like, hey, Helm charts. CDK has support for adding Helm charts, so let me do that. I tried to do that. It did not work out very well for me. It would go ahead and this would run and it would succeed, but then it wouldn't actually get added to the cluster. So that was a little unfortunate. I think part of the reason here, I found some GitHub issues where it said some recent versions of the Helm chart weren't compatible with 119 of Kubernetes on the EKS cluster. I don't entirely know. What I ended up doing though was just kind of creating my own manifests that I pushed up to the cluster. So let me go and see what that looks like. So I created this little plugin here, my cluster autoscaler, and this is just a kind of a bare Python class. And in here, all I'm doing is, kind of tagging the node groups, which is necessary for the cluster autoscaler, creating a service account, which gets used to scale the nodes up or down, and then adding my manifest. So this is pretty straightforward again. For the cluster autoscaler to work, you just need to tag those node groups so it knows it can see which ones are there. And know which ones to manage, and then create that service account. Again, this required a lot of kind of finagling to figure out what the right way is to do this because there's a lot that goes on behind the scenes. So when you create this service account, it also creates an IAM account, and it also kind of adds all the proper trust relationships to the IAM account. So there's a lot of magic happening behind the scenes, which is cool, but it's a little bit confusing sometimes to really understand what is happening. And then it goes ahead and generates a deployment spec. And again, this is mostly just copied directly from the autoscaler repository. And I'm just defining, the cluster autoscaler there, and then all the different command lines for it. The only, couple tricky things I had to put in there, I just had to make sure the cluster name was put in there as well as the region. And then, of course, all the role-based access control rules. And that's just, again, pretty much just copied out of the cluster autoscaler repository. So that was pretty tricky to get that up and running. But now, if I go back to my console and look at EKS, you can see I've got my data team cluster in here. So this was, again, created by EKS. I've got one instance in there right now, and I've got a few workloads in there. You can see there's my cluster autoscaler. It worked. And it scales the cluster up and down when I need it to. I was also trying to add the Kubernetes dashboard and give it a pretty name in there, but I haven't been able to do that yet. That one, it successfully installed with the Helm chart, but I need to kind of dig into it a little bit more. So that's the EKS side of things. So once I had EKS up and running, if I go back to my app, now I can create my EMR container stack and pass in the EKS cluster that I added. So if you're not familiar with EMR on EKS, this was announced back in December at reInvent. You can now run EMR on EKS. So if you're used to using EMR and EC2, that's a very cluster-centric model because you spin up a cluster, you let it run. It may be long-lived or it may be short-lived, but you essentially like run that cluster and you run a bunch of jobs on that cluster, and then the cluster spins down. With EMR and EKS, you're running it on Kubernetes, and it is very job-centric. So you spin up a job, you get the resources you need for the job, and then all those pods, spin back down, and you have a specific IAM role associated with that job too. So creating that virtual cluster, I dig into that file. That is, again, you just need to configure EKS with a few things. So you need to create a new namespace in there. You need to create a cluster role for EMR. And then you need to bind the role to an EMR containers user. Once you've done that, you need an IAM execution role. And then you can finally create your virtual cluster. So that's what this particular stack takes care of. It goes ahead, creates all those EKS dependencies, and then links up the EMR virtual cluster with EKS. And again, there's a bunch of RBAC rules that need to get added there, a few other things like role bindings, and then here's the job execution role. And of course, I've given this full access to so many things, and so I'll scope that down later. But again, during the testing of this, I just kind of gave it access to a whole bunch of stuff. So, all right, let's do this. All right, cool. So that is the job execution role. There's a few things to call out here. One is the trust policy. You have to add a trust policy in order for some of those execution roles to work on the EKS cluster. That can be a little bit tricky to figure out, especially because some of those values don't resolve until after the CloudFormation stacks are created. And so what you have is you have things like this where you actually need to create some CloudFormation JSON output that takes the output of another stack and kind of marries it with this stack. So I had to do that for some of these things, specifically the OpenID connect strings and stuff like that. I had to use that approach to be able to get those out and set those up properly. So that's all there. And then finally that's done. So if I go back to, where is EMR? So there's EMR. And then here is my virtual clusters. So I've got my data team EMR cluster. And this is pretty straightforward. It connects to my EKS cluster, and it connects to the EMR jobs namespace on my EKS cluster. And you can see I've already run a few jobs in there. So that is, let's see, I got the VPC created, I got the RDS metastore created, I created an EMR on EC2 cluster just to kind of populate the Hive metastore, and then I created an EMR virtual cluster along with EKS. So now I can run my EMR on EKS jobs and connect to that Hive metastore. It's, you know, once you get it all up and running, super simple, right? So I've got, let me go back to the EMR containers best practices guide. So if you do have a Hive metastore that you want to connect to using EMR containers, you just have to do a couple things in order to connect to it. So one, of course, the EKS cluster is going to need to be in the same VPC or have access to that RDS database. And then you need to configure your Spark job. So this is how you typically configure EMR and EKS jobs. If you haven't seen that before, you specify your virtual cluster ID, your execution role, the EMR release label you want to use, and then your Spark job information. So in this case, what we need to do is we need to look at the Spark submit parameters. And what is there is, they're called out a little bit down here. So you need to provide your jar to connect to the database. In this case, we're just using a MariaDB connector. And then you need to provide your connection options. So you provide the class name of the driver, username and password, and the connection string. We're going to use a simple sample script here that just kind of does a show databases and does a count. I've modified this one a little bit, so let me flip over to that. All right, so, yep, that's cool. So there's a few things we need to do first. Like I mentioned, the secrets are all stored in RDS. And so when you build up that RDS stack, you get the secret ARN out of that stack, and you can kind of pull out the secrets from there. So I'm just pulling out these secrets from the command line. And so if I echo RDS username, for example, I should have my admin username there. So I'm kind of building up all the database connection strings from those secrets. I could do that in another script or something like that, but I'm doing it here. You need to have the MariaDB Java client jar and copy that up to an S3 bucket, right? And then you can run the code. So this is the code to submit that job to the EMR on EKS cluster. So there's an AWS EMR containers start job run command. You provide the EMR cluster ID, the execution ARN, and then your job. So I'll show the Hive JDBC code in a second, but this is where we point to the jars. And let's see. Then we provide all the all the information there. And if I wanted to, I could probably add support in my PySpark job to read the connection password directly from the secret. I'm just passing it in from the command line here. So just a heads up, that is being exposed right there, and then your configuration. I'm also going to log some data to CloudWatch too. So let me go ahead, copy this, and let's see if this runs. I swear I haven't run this before. All right. So that goes ahead, submits a new job to my EMR virtual cluster. So let me switch back to there. And let's see, that is back over here. So if I refresh, we can see I've got my dacort Hive job. It's submitted. And if I go back over to the cluster, where's my EKS cluster? And refresh here, we should see a job popping up right there. Awesome. What I'll do is also click view logs there. And if I look at this Hive job, what the Hive job is doing, again, it's very similar to that sample code I showed you in the other section. I'm just doing a show databases. I'm going to do a count from my Rapid7 database that I created earlier on EMR and EC2. And then I'm going to see if there's any new fun subdomains on Starlink, because I am in a location where I need access to Starlink, and I want to know, is there anything new going on there? So that job, that Spark job is running. One of the cool things about EMR and EKS is when you click that View Logs button, it pops open a Spark history server for you. So this is the Spark job that is currently running on that EMR on EKS cluster. And it doesn't look like it's spun up yet. If I go back to here, let me do a how do people pronounce that? Is it cube control? Cube control? I don't know. But let's get my pods, and the namespace we'll use is EMR jobs. I think I'm in the right cluster. Yep. Okay, so we can see that we've actually got the driver is running, but the executors are still pending. So probably what's happening, if I go back to my EKS cluster, I bet you, where are you? I bet you that I have some new nodes spinning up because I installed the cluster autoscaler, right? And so now the cluster didn't have enough capacity for those nodes, and so now it's, or for that job, and so now it's adding new capacity for that job. I love the cluster autoscaler for that purpose. So pretty soon, if I refresh this, I should see some executors here. I should see those executors start to run. There we go. They're doing container creating now. So there's a few different pods in there in that EMR jobs namespace. This first one is the job runner. And so this is the thing that kicks off the Spark driver, which kicks off the Spark executors as well. And this is an EMR component that downloads the necessary containers, configures the commands, and gets everything running and monitors that job during the lifetime of that job. So I think let's do logs and EMR jobs, and it's going to tell me I need a specific namespace or a specific container too. So if I do job runner there, get the logs of that job runner, that should kind of tell me what's going on with that job. So there's the Spark job, it's currently running, and you can see all this stuff happening behind the scenes, where we are pulling down the different containers, spinning those up. There's the container image and all that kind of stuff. So those jobs are probably running now. Actually, I don't want the logs, I just want the pods. So if I go back to here, that job is running. So now you can see my show string command there has a bunch of tasks that are executing. And so this is going ahead, connecting to that RDS database, running those commands and dumping those out to standard out. Now with my job, I'll go back here, and I configured my monitoring to log out to CloudWatch. So I'm actually logging out to this EKS Spark location. So if I pop over to CloudWatch, and let's see, refresh, and let's pop that open. So we have the Spark driver standard out and standard error, as well as the Spark executors standard out and standard error. So let me open the driver standard out. And when I do that, you can see all the different log messages coming out of that Spark driver. So this was the output of the show tables command. And this is the output of just the count star of the Rapid7 DNS table. And then there was one more command. Oh yeah, the Starlink thing. So that's running there as well. So let me see if that is finished. that one takes a little bit to run just because it's doing a comparison there. So looks like it may have gone beyond that stage. Cool. Looks like it's still running. That'll take a little while to run, partially because it's spinning up some new nodes in there. I think those nodes are ready now. If I go back here, they should, yeah, they're all running. So um, next time when I submit the job, I might submit it with some more Spark executors, because right now I'm only doing, let's see, I think I'm just doing one Spark executor instance. Yeah, I'm not even specifying the number of instances, just the number of cores. So that is something I should probably bump up the next time I run this. I forget what the default is. I think just 2. Cool. But anyway, so yeah, that was connecting to the Hive metastore. Now, way back at the beginning of this, I also created a glue data catalog. So I don't have the code ready for this right now, but you can also use EMR containers to connect with the glue. And maybe I'll just go ahead and do this. So let me, yeah, let's see. That's a different one that I ran earlier. Oh, there's my RDS database. You can see all my connections kind of flowing into the RDS database. Let's go back here. This is still chugging along. So while that's chugging along, let's see if I can write a quick job to connect to my glue data catalog. Because what I did, so I created this crawler, and I did this using CDK. So I created this crawler, crawled a couple different things, and then created a couple different tables as well. So I've got my GitHub table that's got some stats in there. Oh, cool. So that's all the different stats from um, all the different data there. And then I've got my YouTube one as well. So clearly I'm not a YouTube star because this took me about 20 minutes just to get this set up. But what I've got, I just want to look at some of this data. So I think I'm going to look into statistics, and statistics has a view count. Okay, cool. Let's see if I can make something really quickly that queries the glue data catalog. So this is cool. So this is RDS. Now let me do glue. So I'm going to create a quick job here, and this will be I'll just call this glue spark.py. And so from here, I don't need to create a table. I've already done that. What I want to do is, let's see, I'm probably going to need to specify the table name, database name, and table name. I am going to do another quick show databases in there though. So we'll do a show databases, and let's see if damonsdatalake.youtube. Isn't that just a fun query? All right, cool. So that is Python Spark SQL glue integration example. Cool. So let me go back to here, and what I'm going to do is, here is the configuration for the EMR and EKS job, and this is going to be pretty straightforward, I think. So what I'll do, I'm just going to copy my shell command from before, and instead of all those Spark submit parameters, I'm going to use this this one here. Okay, so I just need to take out everything that is unrelated to RDS. Cool, that was easy. And then the other thing I need to do is I need to tell it where to, or I need to just tell it to use the glue data catalog. So in the configuration overrides, if you're familiar with EMR and EC2, you can override different pieces of the configuration in order to connect to different things. And so we're going to override the Spark defaults here with our Hive Metastore client factory class. So let me go ahead and just copy this application configuration out. Cool. So configuration overrides. Awesome. Let me go ahead and pretty that up. Oops. Got a syntax error. Probably because I might need to submit a PR for that. Okay, cool. So there is our Glue data catalog Hive client factory. So I think that's actually all we need to change. I need to change this job here. So instead of Hive JDBC, I'm going to call that Glue Spark. And then S3 copy, let's see, Glue Spark up to my bucket. Sweet. So let's go ahead and run this job and see if it fails. All right, let's go back to my EMR virtual cluster. Did that job finish? Let's see. It looks like it is still churning away. It's still doing a bunch of stuff. So let's see, still going through that stage. Oh, it's doing another stage now. Okay, cool. That's doing a lot. Actually ran a lot quicker last time I did it, so I expected that to be a little bit quicker this time, but it looks like it's just kind of churning through some stuff. So we'll let that keep going. And let's see what this other job is going to do. So if I go back and let's do a get pods again, we should see another Spark driver pod that spun up. So now we've got 2 Spark drivers and then 2 Spark executors. Oops. Yeah, so here's the Python Spark SQL glue integration example. Woohoo! Awesome. I should have changed that to dacort glue. My bad. Cool thing is too, when you set the app name there, that kind of gets bundled into the pod name as well, so that can be kind of useful. And these are both in pending state right now. And let's see if our EKS cluster is spinning up some new resources. Not yet, but I bet we've got some logs in CloudWatch. So let's go back here and I'll refresh this because I think this is a little bit old. And yep, there we go. So now we've got a new driver standard out there. And sweet, yep, here's Damon's data lake. And let's see, there's a Damon's data lake table or database. There is a default database, and I wonder how that job is doing. It may have failed. My query may have failed. I'm not sure, but we'll see. Still running apparently. Cool. I feel like that should have finished pretty quickly, but it may still be in a. Let's see what it's doing here. The other thing you can do too is you can get the logs, directly from those pods. Oh, there, see, those pods are still in pending. Interesting. Okay, that's why. So yeah, the show databases command, that doesn't need the executors to run. That can just run on the driver. So that executed immediately, and then this count star one is taking a little while to spin up because that actually requires the executors to go and spin up and execute that. Excuse me. I guess you're still pending, so you won't have any logs. So that might take a while to go ahead and finish. I wonder if is the EKS cluster giving me any more capacity yet? There we go. Now we've got some more capacity. Sweet, those actually just spun down already. So if I go back to CloudWatch, refresh here, I should hopefully see a count. I do. I have 6 records in there. Awesome. Cool. So I think I'm gonna pause here. Let's do a quick recap. So the main goal of all of this was I wanted to be able to do a quick demo of EMR containers integration with a Hive Metastore, but doing so, of course, requires having a Hive Metastore, having it populated, having it in the same VPC, doing all this kind of stuff and getting it up and running. So I took it a little bit too far and built a CDK stack for this demo. If I hop back over to my CDK stack, I'm pretty happy with it. It spins up a new VPC stack, new RDS instance. This was not necessary, but I also built an EMR stack that I could use, just EMR and EC2, in order to connect to my my Metastore, and then built myself an EKS stack that I can use to run my EMR container jobs. And then here is my EMR container stack, and this all deploys, really, really easily. So there was, let's see, I did want to kind of mess around with changing something in here, but I don't think I'll do that right now. But I think let's make one quick little change. So just to show like the CDK CDK stuff, because the CDK stuff is really neat. So I make one change here. I can do a CDK diff, and you can pass in parameters to CDK as well, which is really nice because it allows you to parameterize your stack. But then it goes through and it compares the two different stacks. So it can actually say, okay, here's your EMR cluster. Probably needs to be replaced because we need to change the number of instances from 1 to 2. I wonder if this may replace the entire stack. I don't know if it will, but then I could say CDK deploy, and you can deploy a single stack or you can deploy all stacks. I wonder, I usually just do deploy all, but can I just do deploy EMR stack, or do I need a parameter for that? Cool. That actually went through and is deploying just the EMR stack and included the dependencies, because CDK figures out those dependencies for you. So it goes in and figures out which different stacks you want to create. But yeah, now it's going to go ahead and update that EMR stack. And so if I go back to CloudFormation here, what I'll see if I refresh my stacks over here, my EMR stack now has an update in progress, right? And if I go to my EMR stack under events, what we can see is it's doing that update. If I click on resources and refresh this, we should see whether it's updating or deleting that cluster. It looks like it is just updating that cluster, so that's kind of cool. So if I go back to EMR, and again, that's just CloudFormation, right? CloudFormation is figuring out what it needs to do to update those resources for you. If I go back to clusters, there's my EMR cluster, and you can see it's already starting a resize on that cluster. So now I can have a little bit of a bigger cluster. So that's, whew. I'm going to publish all this on my on GitHub, so you can poke around with it and follow along as well. But that's my stack. So yeah, pretty sweet. I've got my EMR stack with all the dependencies that I need, including EKS, including RDS. I've got my sample, glue and Hive jobs here that I can run on EMR and EKS. I've got my data container stack that is, pulling data from places and automatically crawling it with glue and creating tables in glue. So I'm really, really happy with this because just, makes it so easy to put all this together. I'm getting choked up. Makes it so easy to put all this together. But that's all I'm going to talk about today. So thanks for those of you that hopped on. And, I'll leave this up here and hopefully you'll find it useful. And I hope you all have a really nice weekend.